h to the 0 is also increasing by 1. But the most important fact is that the sum of the two exponents is actually equal to n. And so continuing the expansion, so we've got the first, we just listed the first three terms. So let's just list the last two terms here. So it's going to be n cn minus 1 times x to the power of 1 times h to the power of n minus 1 plus ncn times x to the power of 0 times h to the power of n. And that's the binomial expansion here of this particular term here. And what we need to do is we need to subtract from that minus a times x to the n. And this all needs to be divided by, h. It looks very complicated, but it's actually quite straightforward. The most complicated bit is just the binomial expansion of this particular term here. And I will put a playlist together that deals with the binomial expansion of things that look like this, of these types of expressions. So now if we just multiply in by a, okay, so we just multiply in by a here just to do it, this becomes equal to the limit as h tends to 0 of a times the first term gives us a times nc0 times x to the n. H to the 0 is just equal to 1, so we can lose the h to the 0, plus a times the second term, so it's a times nc1 times x to the power of n minus 1. H to the 1 is just h, plus a times the third term is nc2 times x to the power of n minus 2 times h squared, plus all the way through to a times the second to last term, so it's a times nc n minus 1 times x times h to the power of n minus 1, plus a times the last term, a times ncn times x to the power of 0 is just equal to 1. So 1 times h to the n is just h to the n. And then we have to take away this term here is minus a of x to the n. And this all needs to be divided by h. But the most important thing here is this, is that nc0 is just equal to 1. So recall that nc0 is equal to 1. And also ncn is equal to 1. Also maybe recall that nc1 is equal to n, and also ncn minus 1 is also equal to n. So just some important, let's say, combinations. The first one is that nc0 is equal to 1. The number of ways that we can select 0 objects from n objects, there's only one way to do that. The number of ways we can select n objects from n objects is only once. And the number of ways that we can select 1 from n, there's n ways to do that. The number of ways we can select n minus 1 objects from n objects, there's n ways to do that. So just keep an eye on them particular coefficients associated with this binomial expansion. So this becomes 1. So now look what we have. We have a times 1 times x to the n is actually just, this is actually the same as a times x to the n, but we have a minus a times x to the n here. So this whole thing here is going to cancel with this thing here, okay? Which now leaves just this part of the binomial expansion. So this now becomes, this is equal to the limit as h tends to 0 of a times nc1 times x to the n minus 1 times h plus a times this term nc2 times x to the n minus 2 times h squared, plus all the way through, plus this term a times ncn minus 1 times x times h to the n minus 1 plus a times ncn times h to the n, which all needs to be divided by h. But what we have here is we have a common denominator. We have across all of these summations. So we can actually break this up into a summation of terms with each term divided by h. So this now becomes the limit. I'll just push this up here. Okay. So this now becomes the limit as h tends to 0. nc1 is just n. Okay. So this is a times n. This is a n times x to the n minus 1 times h divided by h. Okay. Plus this becomes a times nc2 times x to the n minus 2 times h squared divided by h plus, and this term here is a times, ncn minus 1 times x times h to the n minus 1 divided by h, plus the last term is a times ncn, which is actually just equal to 1 times h to the n all over h. Okay, and you can probably see what happens here is this h cancels with this h cancels with the square, this h cancels with one of these h's here, which gives us now that this goes to the n minus 2, and this h